All right, welcome to week 4 of mixing and mastering. We're going to talk about such a interesting tool. I thought we got a lot out of EQ, but together, EQ and compression, you've got in these two steps such a wide amount of control over, really laying down a great foundation or the foundations for a really great mix. Um, I want to thank Robert and Dante for their presentations. I'm going to try to sidestep the information that they presented and kind of work around that. There, of course, will be some overlap, so you'll just have to, be patient on that. So I want to make sure, to hit these topic points, talk a little bit about where compression came from, and in doing so, answer the question of why do we even have this. Then, of course, how they work um, and the kind of sound that comes as a result of this tool we have, and then looking at the most typical ways that you would be expected to use the instrument. And so these don't include some of the more creative or artistic ways where I think in current popular music, compressors are being really pushed to the limit to create some sounds that are not necessarily natural, but they are unique. And so those are good to know about. For my purposes, I want to make sure that you guys have the sound foundation of, and by sound I mean, stable and functional in terms of the basic applications. There are a few tricks I think that are obviously useful, especially when you do the kind of work on making kick and bass guitar work together, so making room in the EQ spectrum. And then we can review a few definitions at the end. So, just in terms of the history, in the 1920s, we have this new, entertainment medium called radio, which is an audio only medium of reaching mass audiences, and the early equipment could sustain catastrophic damage due to spikes in volume and gain and loudness. And so while those terms are technically distinct with some overlap, the general idea is that if the audio is too powerful, then it can damage the transmitters and cause the radio station to go offline for a certain amount of time. Depending on how fast the choo-choo train's going to make it with the new part or horseback. Trying to think of what life is like in the 1920s. You got cars. I mean, things can get around. Anyway, and so, the obvious way to deal with that at the time is you just turn it down by hand. But, over a certain amount of, months, weeks, years, however long, that's going to get a little old. And so having an automatic gain reduction system was critical. And that's kind of where compression comes from. And so some of the early compressors, used electron tubes. They're referred to as variable MEA. They don't allow you to adjust, what's referred to as the threshold. And these devices also could be turned up, like one of the controls, which is the ratio. If you turn it up all of the way to where you have an infinite amount of compression, then it simply is a hard limiter, meaning it won't let that signal go past the threshold, which is basically where the compressor starts to do its job. So we'll go over some of those terms in the subsequent slides of the present. So as technology develops, there are distinct differences between the old school analog compressors and the new digital compressors. Digital giving enough sort of exact control that you start to lose some of the character, I guess, it's associated with analog compressors. That's essentially tied to the fact that they are less exact. And some of the gold standard compressors, like the LA2A compressor or the 1176, are both recognized and can be thousands of dollars, but are in fact less exact than a digital plug-in compressor that you can use with your Pro Tools bundle. So some of the types of different compressors that you'll find, we talked about active are fixed versus variable threshold. Usually a good compressor will allow you to move the threshold around, and that once again is the amount of decibels, so the amount of loudness that the compressor is going to start kind of focusing at that point and above. But some, an active compressor is one that you'll actually need to, turn on, and is going to be fed, operated with electricity. But there are passive compressors like the 1176 that simply work on sound as it passes through, and are sort of like a DI or something like that, or a volume control. So these are examples of passive circuits. So you've got how to understand the way compression works. I like the metaphor that the texts use, which is it's like the gravity pull of sound, and so a compressor is going to make it harder for sound to become louder as you turn the ratio up. And so the 1-to-1 setting is basically no compression at all. That's kind of like unity gain for EQ. So there's really nothing that's happening. But when you put it at 2-to-1, it requires twice the sound energy to go 1 decibel higher. And so 3-to-1, 4-to-1, 5-to-1, etc. Until you get to infinity to 1, which is it doesn't matter how much energy you apply, the compressor is going to hold, or in that case, it's acting as a limiter, is going to hold that level steady. And so let's move on now and take a look at the 1176. So you'll see here there is no threshold setting. You can adjust the amount of gain coming in with the input, the makeup gain, since you're actually the work of the compressor is going to result in making the sound quieter or more kind of having a hard time reaching the peaks of volume that it did. It's common for compressors to have an amplifier included, and that is what the output knob there refers to. So that's the makeup gain. Attack and release, these are time sensitive. We'll talk about them in a little bit, but for percussive sounds, the attack is very fast on that. So when you hit a drum snare with a stick, that attack happens within within milliseconds, and so you'll need the attack on the compressor to mirror that, or else you won't be able to focus on that early part of the sound envelope. And the release is how long the compressor is going to hold on to that sound event before it lets go. And so those are time sensitive knobs, the attack and the release, basically indicating at what point within the envelope, from attack to decay, sustain, and release, that ADSR equation, or what is that? That's there's a word for combinations of letters that all refer to words, but anyway. So you can also see that the 1176 has fixed thresholds like many do, but these are just push buttons. So there is no 3-to-1, which is a common starting point, but instead you go 4-to-1 is the lightest. So the 1176 is going to be a pretty powerful compressor. It doesn't give you hard limiting, so it stops at 20-to-1, but that's still a ton of compression. The meter can work with actual sound that goes, a typical meter is going to be at rest on the left-hand side, and then as sound goes through, it'll show you how loud the sound is, and so that's +4. and +8. But if you press GR, that's gain reduction, and it does the opposite. So it goes to rest on the right-hand side when nothing is happening. And then when the needle moves, it shows you how much of that signal the compressor is basically compressing or working on. And so that can be confusing to students when you press GR and the needle looks like it's wide open going all the way to the right hand side, but that's in fact where it's resting. So that's 0 dB, not by the meter but by the compressor's sensitivity controls, because 100% gain is 0 dB. But anyway, that's a little bit beyond the scope of what you need to know there. So there are some secondary, those are the primary controls. The secondary controls would be like adjusting the knee. And so for a sudden loud transient, a hard knee is the appropriate response to that. Typically, always let your ears be your guide. But if you want the work of the compressor to be more transparent, like for example, when dealing with a voice, you don't really want to show your hand there and the fact that you're using this tool, to adjust the voice. It's best for voice to sound natural 90% of the time, but I'm sure there are situations where, like in heavily distorted or very aggressive forms of music, like for example, death metal, having a heavy compression to the voice, I think would be a good fit there. Whether or not you use hard or soft knee would definitely be a matter of your that's kind of season to taste, I guess is what I'm saying there. So when it sounds good to your ear, you have an artistic license here to do what you need to. So in terms of like this, what this compression sounds like, even though it is smashing or making it harder for sound to be loud, I guess you could say, the sound of compression typically is bigger, more dense, more fat. You kind of can hear the interior details of a given sound that you're compressing, so it's kind of punchy, but it also has less dynamic range. So you're reducing the amount of distance from distance in terms of vertical distance or decibels from the highest peak to the lowest valley. And so when you look at this chart on the right here, you see the dotted line. That is the threshold. So when the dotted line is set low like that, you're not just working on the peaks, but you're working on everything above the dotted line. And so that's, in this case, 80% of the available waveform. And so when you compress 80% of the waveform down from, in this case, 5 dB to 3 dB, if you're looking at the difference between A and B there in the lower picture, then you use the makeup gain to put the new waveform back up to 5 where it started. You can see how thick that new waveform is compared to the first one, where so much of the gain was really limited in that sort of attack and decay. Now you've got a lot of your decibel, a lot of the energy is distributed more evenly between the sustain and release, the additional parts of the envelope, and so you've just got a more substantial waveform there. And so that's where you get this kind of denser, fatter, stronger, punchier. Those are the kinds of terms that are associated with effective compression. So to review kind of how it works, you've got a copy of the signal that comes into the system, or the signal comes into the component, the compressor, and a copy is made, and then the threshold identifies how much of that waveform it's going to work on, and then any of the sound energy above that threshold is isolated, and then that's where the compressor goes to work. And so to see that, and then after it compresses, it reinserts that its work, right, the process of compression back onto, it maps it back onto the original signal, usually creating a modified envelope. And so this is a visual representation of that. So A at the top shows the signal coming in. B is you're setting the threshold. and everything above that becomes what's in C there. So it's just those two blocks. And then in D, you're going to cut one of them off because it's a 2-to-1 ratio. And so 2-to-1 basically means that you're taking 1/2 as opposed to a third and or 3/4, et cetera, as you compress more and more. And then you sculpt it with the attack and the release. And so that shape, that wave shape there in picture number E, or letter E, is basically 1 millisecond for it to go from 0 compression to full compression. And so because that chart reads left to right in terms of time, that's why you're getting, from 0 to 100% over a millisecond is going to curve it like that. And then when it releases, you're going to get the same curve, just the reverse shape of it. And so, and then finally, when you get to F, the compressor is inverting, using phase to turn it from a positive to a negative energy event. And so it's no longer read as a boost in the signal, it's read as a cut. And so when you reapply that that new waveform over the existing signal, it cuts it in a very specific way. And so that's basically what happens there. So typical practice, you're just really containing your mix in a way. And so to see what that looks like, if you have vocals, snare, and bass in picture A above here that are kind of a complete jumble, and you need to vertically arrange your mix to keep the snare under control so that the vocals can ride on top like they're supposed to, you can use a compressor in that way to even out the vocals and then boost the average level of that. And then for the snare, you even out that, and you don't use the makeup gain to boost it up. You just kind of cut it. You compress the peaks and then let them stay low. So that's a way to do that. Hold on a second. Oh, that's a drag. I can't go backwards. Yes, I can. No, I can't. All right. So a couple of the ways that you can use, or the standard ways I mentioned, containing the tracks. That's the one at the bottom. You can also reshape if you want to emphasize the decay. For example, then you compress the attack and then raise the makeup gain, and the decay sounds louder because that's the part that's not emphasize. But if you want to do the opposite and emphasize the attack, you just simply compress the backside of the envelope and then raise the makeup gain, and boom, now you've got a really sort of more impressive attack of the first part of that sound event. And so balancing, loudening is bringing that kind of punchiness and making something more present and massive in the mix. And so these are basic techniques for using compression, and so you can read more about those as you want to. Parallel compression and external side chain. We talked a little bit about external side chain. There are two different forms of side chain compression. One is triggered by the two types of sidechain compression being just based on EQ, and then what's referred to as external sidechain compression. And so we work with the one that's based on EQ, which is to basically carve out your area of compression and allow for another instrument that's in proximity in EQ to have more space. External sidechain compression, however, is when you use, this is sort of a more advanced trick, but you can plug in another instrument into your compressor, and whenever that instrument, imagine that we're compressing bass guitar. And so if you bring your kick drum into your bass guitar external sidechain routing, then the compressor will read the performance of the kick drum, and whenever it reaches a threshold of loudness, then it will trigger the compression of the bass to not sort of get in its way. And so it's typically a very versatile tool to have access to. For more information on external sidechain compression, I do recommend that you consult the textbook. Here are page numbers for some of the different topics and terms that are specific to compression that are a little bit, can be difficult to, I guess, that you just don't hear. So it's specialized terms you don't hear very often. And so there they are. And I do ask you to send questions as necessary and enjoy the class. Take care.